Alrighty, welcome back everyone. Today is episode 9 of Couch Decoder. On today's episode, we're going to create our first heat map, and we're going to actually overlay this over Folium. So we're going to use the same Folium package, bring in a little bit more, use the heat map element of the Folium plugins, use pandas as we've done previously, and actually get some of the tools that you've been learning, do something realistic with it, and create a visual that it would be really tough to create unless you're using like a Tableau or something like that. But even still, Tableau doesn't quite have the capability that Python has. So to get started, we will talk about our objective of today. So we're going to use pandas to create a data frame. That's the first thing we're going to do. We're going to import that data. We're going to clean the data. So we're going to make the data usable. We're then going to visualize the data on a Folium map as markers. So we showed you what a marker looked like last time. We're going to use a circle marker to show you it. And then we're going to create a heat map of UFO spottings in West Virginia. So I think today we have a fun data set. So I went out and found a UFO sighting data CSV that has like 80,000 entities. Yeah, something crazy. But this is all across the world. Now, if you're going to be plotting all of this data, I think for your sake, it's probably best if you stick with a smaller scope unless if you have a really powerful computer. So I'm just going to be using West Virginia. It's been a pretty West Virginia focused series thus far, and I'm going to keep the trend going. So I'm going to do West Virginia, but you'll see how you can very easily change that scope and make data frames for different states and different groupings and things like that. So let's go ahead and import pandas as PD as we have done before. We're also going to import Folium. We're going to import all of Folium, but what doesn't come with that import statement is your from folium.plugins. We are going to import HeatMap. And this should be a from statement. Okay. So we're going to import pandas, import Folium, and from folium.plugins import heatmap. So there we are. We have that going here. So now let's get our data set in. So we're going to say our UFO data frame is going to be pd.readcsv of our UFO sightings data.csv. And you should see, let's see, UFO sighting. Aha, there it is. So it has loaded in nicely there. So we're going to do a US data frame, filtered one down there, and that is going to be, we're going to use the same filtering method that we've used before, where we say of the and country is the field that we're looking at here. So of the country, and that is going to be exactly equal to the United States. That is just how they have it in there. You can see state, Texas, country, United States. And we will get a US data frame, and then we're going to build a West Virginia data frame, and that's going to be equal to West Virginia data frame of, US data frame of US data frame of state slash province, because that is the name of it right here, state or province, and that is going to be exactly equal to West Virginia. All right, so if we do this here, and then we do our nifty little West Virginia data frame dot head, we should see that all of our data is there. So we have all of that. So now we will go ahead and initialize our maps here. So I'm going to do our, we'll call it M, and we're going to say I've done a little bit of work on this before just to figure out what exactly looks good. So we're going to start our folium.map naturally, and our location is going to be 38.5 comma negative 80.5, and this should put us roughly in the middle of the state. And we'll say our zoom start is going to be equal to 8, should give us a rough thing. And I don't really want to see all the highways and everything. I don't need all the city lines or anything. So we're going to give it a more, I guess, woodsy feel background here. We are talking about UFOs. So we'll go Stamen terrain, and that's just a preset tile set. And we will do the exact same thing, but we are going to call it heat map, and we'll actually initialize 2 maps here because as we said, we did want a heat map as well as a marker map. So I guess this will be our marker map and this will be our heat map. So if we do that there and just look at M, see what it looks like, you can see that there's West Virginia. We were zoomed in there. And you can see how it's kind of earthy. You can see a little bit of the terrain there. So pretty cool little background if you're not really needing much of the highways or anything like that. So next here, we then need to actually do a little bit of data cleaning. So there's a couple things that could go wrong here that I've seen throughout the whole data set. So I've seen the latitude and longitude actually has a error where there's some letters in there and things like that. So just to handle that, we're going to try to make the latitude and longitude floats. So to do that, we're going to use a try and except statement. So we're going to say for index and row in West Virginia data frame dot iter rows iter rows, and that's just iterating through each of the rows, and we're going to use a try except statement. So basically what a try except statement is it's going to try to do something, and if that errors out, then it's going to do the except statement. So I'll do another one of those episode zeros on try and accept statements. Maybe I'll create a little niche of an episode itself, just demonstrating how these work a little better. But we're just going to use try except for our data handling here. So we'll do, we're going to try to convert the row of latitude into a float as we've used before. And if it's not able to do that, then it'll drop it to the except. And in the same instance, we also want to see if the longitude is a float as well. And if we don't do that, we want to drop the index within there. So we actually need to redefine that. So basically, if it fails at this point, then it is going to drop that row, and that will be our new data frame. It'll be that data frame with the missing row. And if that happens, then we will just go ahead and print row and index dropped. Okay. So we'll go ahead and run this and just see what happens. It looks like we didn't have to drop any rows there. So I'm going to go ahead and, for sake of argument, I'm going to go ahead and open that guy up. Let's see. I'm going to open up Excel actually and have it on my other screen here, but I will open it. All right, so we have the data here. I'm going to go ahead and just insert one here, and we'll take the time and date. We'll say the city was in good old Morgantown, and that would be in West Virginia, US, so that satisfies our field. Let's just say it was shaped like a circle. This doesn't matter. Described test unit, description test unit. The date, just use the date above it. And here for our latitude, and this is where we need to give it an error so that you can actually see that this is working. So we'll say that was 27.GJ, and this one was a normal negative 80.5. There we go. So I'll go ahead and save this guy, and we will refresh this here. And when we run this again, we should see that we drop one of them. We'll restart the kernel here, and we should get it this time around. So we'll run this guy straight down, get back to where we were, and it dropped row 4, which was where we added that false data. So that's exactly what we happened. That's a little bit of cleaning your data and seeing how you can do that. So the next thing we need to do in cleaning our data is we need to actually drop all of the NANDs. So we need to make sure that of here, so you can see there was that, but we might have a latitude or a longitude that doesn't have a value associated with it. This happens a lot in data, especially when you're working with an 80,000 point data set that, just a latitude or a longitude is missing. So for us to do that, we're going to just say a nice little drop in a function, and we're going to drop, so we're going to tell it how to drop it. We're just going to say all rows that have a NAND value in them. So you can see we run it there. I'm not really sure how many it dropped, but I do know that it is there. So now we need to structure our data to be, or I guess not structure our data, but we need to, add the data onto this map. So we have it in our West Virginia data frame. We can see that's nice and cleaned up. We got rid of that messed up latitude and longitude. We got rid of any NAND values. So I think it's ready to add into there. So we're going to do something very similar to the for index and row above. So we're going to say for index row in our West Virginia data frame dot iter rows. And we want to add a marker for all of them. So before we did folium.circle marker, and that would be of, and then we want our row of latitude, comma, row of longitude. So basically what this is doing is just saying that we're going to be plotting it at our latitude point and longitude point of each row in this data frame. So that's not the only thing that we want about these circle markers. We want to, give it some color, give it a little more, and tell it exactly how big we want it to be. So let's just go with a nice radius of, say, 10. Pop-up row. So what we want it to say if we were to click on this, and let's say we want to know the description. So right there, the description. So when we click on it, we get the description of the encounter. And let's say we want the fill color. Let's go with a red. Why not? I think red's pretty cool. So at the very end, we'll do a nice little add to M, and we'll get rid of that slash there. I don't know how that's stuck in. So if we look at what's happening for each row, we're going to add the latitude and longitude of our clean data. It's going to give it a nice little radius of 10 for each circle. Every time you click on it, it'll tell you the description, and they will each be fill color red. So we click that guy. What do we got here? Key error longitude. Aha. I'm sure many of you saw that. We'll run that again. And now if we press M. Uh-oh. Come on. What we got here? Why are we not one to run? Come on. There it is. So here's all of our little guys here. If you click on it, you should get a little pop-up. Maybe not. What do we got going on? Why don't want to pop up? Sort that out later. But for now, you now have all of your cases throughout the state on that radius 10. You can see that there's some in Clarksburg, some in Morgantown. But you can see you have some denser areas here, right? It looks like there's 2 reports at the exact same spot. You know, how would that get so dark? So sure, this can kind of be representative of a heat map, but I think it'd be much better if you got like a weather heat map or something of the sort. And what's great is that's exactly what this Folium.plugins heat map is here. So that is what we will be doing next. So now we have our nice clean data, but we are now going to the heat map and how to use the heat map. So the heat map actually accepts matrices and list. So for our sake, we already have a data frame in pandas, so we can just turn that into a simple matrix. So we're going to call that matrix, West Virginia matrix, and that would be our West Virginia data frame of, there we go, latitude, comma, longitude, there we go, longitude, if only I could type, and we want to turn this into a matrix, so we'll say as matrix, and there we go. And so now we just need to do a heat map of, and we want our West Virginia matrix, and then we want to add to our heat map, right? Isn't that what we called it before? Heat M. There it is. That is what we called it. Okay. And so you can see right here that it has done some things to add to the heat map. So let's see what that looks like. And there it is. So you can see, as you zoom, the heat map changes, and that's just one of the great parts about this Folium heat map plugin. So it looks like there's a lot going on in South Charleston. To me, it looks like, and it's funny that some roads are present here, it's looking to me like a lot of the reports are happening on highways. So maybe they were some strained eyes drivers cutting through the state. They might not even be West Virginia residents that are reporting these. They could have been cutting through, maybe on their way up to Pittsburgh or through the state. But you can get a lot of useful information out of these heat maps. It kind of looks like a weather map, and you could more than easily apply some weather data into a context like this. So I think that's your coolest view you get out of it here. But I hope you have learned something from this video. You're able to see how you can use a loop to create markers. You can see how you're able to visualize and make an actual heat map. Now keep in mind you're using a 2D array, right? So these things aren't weighted. So if you were to have some sort of weighted data, then you would need to use another solution or come up with a more complex finish for something like this. But I hope that you've made it to this point in the video and you feel redeemed and you can make some great heat maps for yourself with some interesting data. So if you have any questions or comments, you can leave it down below. Otherwise, thank you so much for watching, and I will see you in the next episode.